Welcome to In Depth with Academia. I'm your host, Price, CEO, Academia.edu, and we're diving into a pretty fascinating and, I'll say, unusual new hypothesis about solar system structure that making the rounds of academic circles, or at least the preprint archives. I want to remind everyone up front, as always, my role here is to neuter introduce interesting research, not to endorse. So let's treat this as an open invitation to think and explore. So what's on the table today? We're looking at a preprint by Salah-Eddin Gherbi, an independent researcher in the UK, titled The Harmonic Architecture of the Solar System, a ratio-based hypothesis for planetary spacing. Wow, that's a mouthful, but the heart of it is actually a single bold question. Is there a hidden algebraic harmony based on the so-called Silver Ratio that neatly organizes distances of the planets from the Sun? Now, let back up a second. Why is this important? Well, for thinkers from Kepler to, enthusiastic amateur astronomers have noticed that the planets don't just orbit the Sun wherever, they're kind of spaced out in a way that almost looks patterned, but all the old models have fizzled out in the details. For the Teacher-Sowed law, kind of the classic does until suddenly doesn't, especially with Neptune and Pluto. So, if there's new pattern, and it predicts the planetary layout more accurately, that matter, even if it's only pointing to coincidence, it frame the way. Look at formation resonance in solar systems. Let's get into Gherbi's idea. What he does propose that the semi-major axes, right, those are just the distances from the Sun if you're not familiar. These can be described with a simple rule based on the Silver Ratio. So what the Silver Ratio? It's this number about 1 plus the square root of 2, so 2.414. It's a kind of cousin to the Golden Ratio. It's a pretty geometry there. The model itself is built using something called the Silver Ratio Harmonic Framework, SRHF for short. Basically, you use this ratio, crank through neat algebra and geometry, and you get a sequence of predicted planet distances. Mercury, Venus, Earth, all the way out to Pluto. And here's where it gets wild. The model actually seems to the planet distances with an average of only about 0.7%. That's surprisingly than earlier patterns by about order of magnitude or so, the paper claims. But, of course, let's pause there. This doesn't mean there's a cosmic architect tracing planetary bits with a ruler and compass set the Silver Ratio. It could just be, our brains love spot patterns or just pure math fun. Now, a particularly intriguing part of the study is this predicted planet, Gherbi calls it Harmonia, that says there should be a planet-like harmonic node at about 0.14 AU. So that's beyond Mars and before Jupiter in right among the asteroids. I love Nameonia, honestly. It just right. The model predicts this node almost matches a dip in the asteroid belt. That's been the focus of other what if there once a planet here musings. But so far, no actual evidence of a vanished planet. Don't get your hopes up for secret alien civilizations or anything. How did Gherbi test all this? He took the planetary distances from SRHF model and compared with data, modern JPL NASA-approved numbers so pretty robust. He optimized this node, Theonia point, using statistical tools, Brent's algorithm if you're deep into Python code, and then calculated the total errors for the classic and for this hypothetical gap up. The error was pretty consistently, and the fit for this harmonic node matched up just algebraically, but even with another transcendental formula involving pi the 2/3 power. I don't know, maybe there's some neat math lurking in there, or maybe it's just a coincidence. Again, I'm not weighing in, just presenting real selling point, this model, to the author, is that testable predictions, particularly that if we really scrutinize the orbits in that 2.14 AU region, we might find a real density Ike or something out of the ordinary. And you could, in principle, also look for similar Silver Ratio patterns in other star systems. Would be amazing, but probably really hard to do right now. Of course, the paper is careful, and I want stress too, this is presented as a phenomenological model, not a law of nature. Gherbi doesn't claim there's a new force or a deep mechanism, just the numbers line up in a weirdly elegant way. A limitation is that it only looks at the distances, not the messy planetary details like mass or orbits change across time. if anything changes our knowledge of those semi-major axes, if the dynamic story winds more complex, the pattern could dissolve. There's also, and this is just me, something almost poetic in all attempts to find cosmic harmony. You know, it kind of reminds me how people once tried to tie music and the heavens together. Wait, wasn't there an ancient idea of the spheres? It's such a human thing to want the universe to be beautiful, even if the universe is, and I mean, have you seen Pluto's orbit? Really not obligated be neat. To wrap up, what does this all mean for you listening right now? Well, if you're in how models are built, tested, and, yes, sometimes falsified, this is a case. It's a clear illustration that progress comes from creative, bold proposals, careful math, and a willingness to put ideas up for scrutiny. There's on Zenodo, version 3.0, so you can dig as deep you want. Code, data, all open. Final reminder, I'm not endorsing model, just introducing it. If you're an astronomer, planetary scientist, or a cosmic pattern lover, maybe this gives you something new to think about, or at very least a handy tidbit about why there's a gap between Mars and Jupiter. For joining me, this your host Richard Price, with In Depth with Academia, where curious minds meet creative research. Next, who knows, maybe it'll be golden ratios or something even weirder. Until then, keep thinking, keep questioning, and maybe don't try to align your furniture by the silver, just saying,